Welcome back to Turn Right Machine Works. My name is Keith and we're ready to continue on Heat and Tweak Part 2. Just the other day, probably, I don't know, 4 or 5 days ago, now just trying to catch up with the workload that I got going on, we were given back the cooler to go ahead and continue on rebuilding the housing, but I wanted to go ahead and show you, and I'll give you a couple close-ups of this, that the internal part has been cleaned and all of that good stuff. We have the O-ring and gasket kit. He painted the flange itself, and here's the copper flange that goes on the other side. Alright, now I'm going to set this off to the side because we're really not doing anything with that at all. We did pull out the bolts. Now we made a drawing here because we're getting ready. We're going to be machining off some material here, and we're going to be rotary burn. We're going to yank out these helicoils. So we really want to be able to reduplicate what we have here. There's one thing that we have to check that's left from this, and that's from this flat, that whole pattern is square to this face. It obviously looks like it, but we want to go ahead and make sure. I mean, is it just as much as just going like this and looks like one end, okay? So what we did is we made a drawing. We also took telescoping gauges. We mic'd up the inside bore. The inside is 3.765. It really doesn't correspond with any millimeter. It would be like 0.65 or something like that in the middle of a millimeter measurement. So we just wrote down our dimension there. We took our veneers and we measured the outside of the O-ring groove, and it was 100 millimeters, or just plain old 3 15/16, 3.9375. And then we came to the bolt holes, and we wanted to make sure that we were going to have the whole center, because we're going to be completely filling them in, and we're going to go for new holes. Putting something in here and trying to weld around a helicoil is going to be hopeless to having a really cool job at the end. So we're going to have that much going into this whole face right here. Why not just go ahead and rotary burr out, and let's fill in these ears here and create a new material. We have a helicoil kit. We just happen to have one in house for a 8mm by 1.25mm lead. Now, see how these rock in here? When you're trying to come up with a bolt pattern, or the whole circle is what I'm really talking about here. I go ahead and, of course, you can measure over the outside and then subtract the one bolt. That will give you center to center. But what I did is I take the measurement from the outside and subtract one bolt, and then I take the measurement on the inside and I add one bolt. Then I take those two measurements, which vary just a little bit, and then come up with the nominal or the correct size. Now we need to go ahead and we're going to get this length right here, and let's just go ahead and, okay, 8 to 9, so let's grab us an 8 to 9 micrometer here. A lot of dust in here. Alright, 8 to 9 micrometer, and what we're doing is we're just picking a couple of these good spots right here because we want to know what the overall height of this thing is to get some kind of measurement here. Even though the other end is going through an O-ring and it kind of sticks out, we're just looking to put it back at the right original dimension here. Okay, so we got 8 inches, 465 there. Alright, now we're going to take a couple other measurements just to have, if we have a variable here. 73. 71. See if we can just get something general out here. 67, 68. 74. All right, we're going to be satisfied with that length right there. Now we're just going to go ahead and do a quickie with a depth mic here, and we'll check from this face to the edge of the bolt, 2 places. I was looking for it. Okay, and I think the right shaft is in here already too as well. Okay, 1 inch 38. 1 inch 44. Okay, in all intents purposes, I believe it's going to be square to this face. That's how we'll set it up. I'm not going to squabble over a couple thousandths on a rotation on a flange ring holding in an O-ring fitted component. But I just wanted to go through the exercise of actually making sure that we are square. Alright, now I'm going to go ahead and pull the bolts out of here, and we're going to get you in close, and we're going to go ahead and we're going to pull the helicoils out of here, and then we're going to go ahead, we're going to take and turn it over, we're going to measure this diameter here, and we're going to skim this ring so that we can press that ring into here, and then it'll give us something substantial to forge jaw this, because we're going to forge jaw it in the lathe, and we're going to do some machine prepping on this side, but we're also going to need that piece in here to do all the finish turning, because we want to finish facing, do this O-ring register, and skim the bore that's going to shrink. This bore is going to shrink as we weld around here. There's no way around it. It will happen. How much, and if it's even or not, that's another thing. We just need to be able to telescope in and out and create a true running path to a reasonable bore, because this actually chokes down here. Here's your O-ring groove here, and the O-ring seal out here on the face. This fluid and oil travels in between the 2 O-rings, so this inside center, other than those 2 O-ring surfaces, does not need to be 100%. In fact, actually, if you look in here, there's harmonics, and there's some steps, and there's all kinds of different things that's in this thing from the beginning. You can see that actually when they had the interrupted cut, it's a nice smooth cut. Actually, let me bring you in and see if you can actually see that. Okay, here's a look at it with a little bit of light from another angle there, and hopefully you can see that. But you can see the chatter in here, then the smooth, and that's where it had the interrupted cut there, and then it picked up the chatter again because it was more constant inside. So that bore in there is just clearance for the fluid to flow in here, go around the fins, and then goes down at the other end and goes out. So this O-ring here around this outside is where we're going to face this down till we have new surface to go ahead and weld build this. So there'll be a little bit of material that will actually be borne out, because we're going to have to remove it for the bore, but the bore itself may shrink down with the amount of weld that we're going to be putting out around here. This surface is really good in here, and that O-ring groove is still pretty good. We may polish it just a little bit by hand, but you know, we're not really going to concern ourselves with that. That still looks really good. And I'm looking at the bottom of the groove. We're not all pitted out, so the O-ring has something to press against. And also too, this area right in here probably should have a new coat of paint on it, because the copper insert goes past the inside of this thing and actually has a little bit of moisture in there. Okay, we're going to put these away for right now, and we don't want to lose them. And it's got new washers and stuff in there, so we're going to put that on back into the box right now, and we're going to go ahead and I think we're going to go ahead and turn this over, and we're going to get in here. We're going to measure that for this ring right here. and then we'll go ahead and start tearing into this. After we put away our measuring tools here, we can start kicking some chips here. Okay, because we only have an O-ring on about a ½ inch landing in there, so we don't have much to actually pull a snap gauge through. So we got our inside micrometers here, and we put them together so that we could read this here. And I'm getting anywhere from 3 inches 723 to 725 back and forth here. So we're gonna be turning this and then checking the fit of that as we go, and have a slight press fit to it, just so that we know that we're not going to have a loose ring to help us support this in the forge jaw, so we're not squeezing or breaking this casting here. Okay, so we're going to bore is 3 inches 725 is what we're going to write down. Okay, we got the ring. We set this slug up here. This has already got a nice smooth face on it, and this is all pretty well turned, and it turns pretty darn true in the lathe here. So what I'm going to do is I'm going to drop this in, and we're going to go ahead and crank the tailstock in here so we're nice and firm press against there. Alright, we're going to go ahead and we're going to give it a moderate feed here. A little bit fine of a feed because we're friction driving, so we don't want to create too much of tool pressure. We don't want to spin it in there if we don't have to. Alright, and not super fast on the speed. Alright, we're going to crank this in a little bit. We're going to give it about 25,000 to test out the cut. That ring's got to be pretty good material because it is starting to turn golden brown after it gets away from the bit itself about an inch. I'm not going to worry about reaching in and grabbing that until I get it cut as far as I want. I'm going into the base material just a little bit. Okay, now I'm going to feed it back. Now I grab my pliers and go ahead and try to pull this out. You can also pull your center out if it is too jammed in there and reset your piece if you want. We're probably going to crank up the chips a little bit now. We're going to see if we can get them to break. But we got to get a diameter on here, and so we know where we're at. Okay, we have about 125 thousandths to go, maybe 127. Alright, I doubled up the feed grade on this. This is another 25 thousandths. Light coat of oil. I'm not really brushing a bunch on there. Chip has a nicer curl. It's not so wiry. They are breaking and snapping. See if I can take another cut without adding any oil to it and see how it cuts and whether you get a good view of it or not. And we can afford another 25. There we go. Now we're getting the full purple out of the color there, but the cutting oil makes a big difference. See? It stays a constant little curl. The cutting oil does help. Alright. Okay, we just popped off our tool holder. We're using the D&MP, but a right hand versus a left hand. And we broke that edge there. Now we're going to go ahead and we're going to pop it. And we're going to flip this thing around. And we want to break that edge on the other side there too as well. Okay, we're locked in there. Yeah, it's keeping it pretty true. We don't expect it to be 100%, but it does look pretty good. Alright, now we mic this out in a 724 right now after we ran the emery on it. And we're going to check it in our housing. That feels like it wants to go in. Let me grab my plastic helper here. We're almost 100% through on that diameter there. I might actually pop that out a little bit. Well, it does look like it's a little high here. Yeah. We're in there. I thought it felt good. A little tiny bit right here. Okay, now we know that we can go ahead and forge all this, and we know that this band out here is going to be holding true, and we're not going to be distorting this piece here or taking a chance on cracking it. And we're going to be able to hold that substantially out, that distance right there, to do the machine work on the end here. Alright, so we got a couple things that we got to do. We got to pull these helicoils out and go ahead and rotary burr these open and clean and get this ready to get in the forge jaw. And we need to go ahead and change out the forge jaw on the lathe right now. Okay, let's go ahead. We got to change out our chuck, so put that in low gear. We keep our little spanner wrench back here. Okay, and we'll take it out of gear here for a second. And alright, we've got this cleaned off and this sitting upright. The key is facing up so that we have the two flat mating surfaces and holds it parallel so that the threads will line up as it screws together. And you just make sure that there is absolutely no dirt or grit in there. It doesn't fall down on. There we go. Okay, once that's level, then you can screw your chuck right together. Alright, put it in gear. Alright, grab the spanner. Alright, now we'll wipe up our outside surfaces here. And always keep this squirted down with some kind of a light oil and keep the most of the rust off it as possible. Okay, before we go put this in the lathe, I want to go ahead and make sure, because there is a couple of dings and stuff around this outside edge. So I've got this. I keep this paper up here until the paper's no good. It has some stains and stuff, but it still does the job. I took the air and I blew it. So what I want to do is just do a light lap so that I can see that I'm flat. All right, there's still just a little bit of a raise right there. All right, that's nice and clean. Okay, even though we're going to be machining this area right here, let's go ahead and see. Let's see how much. Well, when the sunlight, or yeah, the reflective light hits it, I can see that we do have pretty much right here, right there, right over here and here, all mating up pretty close. Alright, let's go get it in the lathe. And now that we know that we can put this face right against the chuck, hold it nice and flat, we're going to take the big bell center, we're going to bring it in here, and then we're going to bring the 4 jaws in with little aluminum pads and grab a hold of this. And then after that, we'll back out the center, we'll put the indicator in here, and we'll get this thing dialed in. Alright, and we just make sure we don't feel no grit right there. I'm just holding the flat upright here, and we'll pull our center in here. And I'm just cranking it. I have a certain amount here that I probably want to have sticking out of here. What I'm doing is I got my tailstock kind of tightened so that I can lightly set it until I know that we're 100% against the face. We're not cocked one way or the other. Alright, now I'm going to go ahead and just make sure that we're square with everything here. Alright, now up here I always keep some little aluminums just so that I can put underneath my jaws. So I grab 4 of these. Alright, those are looking good. That's what I'm going to use. Now, this is chuck wrench for my other chuck, and I exchanged that out for my hex chuck, and now I won't accidentally grab them because I put them both in the same spot when I'm done. Alright, I'm bringing it over that diameter of the ring so that we'll be engaging pressure without a void underneath it. It'll be solid against that ring. Alright, I'm just giving these a little bit of snugness so that all relatively about the same pressure. Now I'm going to go ahead and back off the bell center, and now I'm going to set up an indicator to where we can reach in the bore, and we can reach on in, we can dial close here, we can dial out here, so that we have 2 points of trueness that will prove our alignment. Right now, it being pushed against the chuck and that face is touching there. We really should be true, and it should just need to be a peripheral adjustment if there is one. Just for the heck of it, let's take a look and see how it looks. You know, that's pretty good to start with. Alright, we got our indicator in there. This is our Intrepid little test indicator, and I'm reaching in here just so that you can get a good view with the camera there, and I got you looking down in the hole, and you can see that that's the low and that's the high right there. Alright, we're kind of in between two jaws right here, so we're going to work a little bit on this one, a little bit on this one here. We're going to be pushing away from us at those 2 points right there. So I'm just going to leave my mirror right there, and I'm going to give a little bit of tension here and here. And then we're going to release a little bit on this side here and this one here. We'll do it again. We're going to do a little tightening. Alright, we're going to check. Just because I can't look in there at the same time right now, and we've eliminated almost half of that. In fact, actually, I'm going to see if I can set my mirror up right here so I can. This is what, you know what, I need to make a mag base for my mirror. Right there. Let me grab a magnet. Yeah, I think I almost got this. Alright. Right there. Alright. Alright, now we got our mirror. Now I can see in there, you can see in there. We're all good to go. Okay, that's the high right there. Straight across from it. The low. We just want to back it off a couple thou there. Alright, here's the high again. Alright. We got just a little fluctuation in there. I think the other two jaws we're going to go for now. Just a little bit on the loosened side right here, and a little on the tension here. Alright, I'm happy with that. That's all the way down in, just a little bit out from our ring in there. Now I'm going to go ahead and we're going to bring this out to where we can get out here. Let's say just inside that open port there. Now this, to adjust this in line, we will be tapping it from side to side. Because this is in close to the chuck, and you work this one in the peripheral here, this one here, you have to move it because you're off an angle. Whether you actually can get anything behind here or not, if you take a feeler gauges, I can actually see a little bit of a gap right in here and a little tighter on that side. And we're showing a difference in the gauge. You know, the gauge is kind of telling us the same thing. Are we suspecting that we are a little bit open right there? Alright, I'm not going to bother going and getting the feeler gauges just to confirm that. I'm just going by a visual here. Alright. Alright, so we need to tap it away from us at this point. That's where I like this plastic mallet. These are real handy to have around just to go ahead and you don't want to put any dents in there. We eliminated some. Here's some more. That looks like about half. Just a skosh more. We're almost about 90 degrees from where we were. Alright, we're within a couple thousandths right there. Now what we got to do is we got to go back into where we were and verify that we didn't move it or we did move it and change it. And then you go back and forth until we're happy all the way in
and out at the point where we're at now, then we know that we're in line with the bore, and the bore is in line with the axis of the lathe. And I was in just about where where this nub right here, I had about a 1/4 inch of clearance here, and we did have just a little bit of a change, but that's like a drop almost. We got to look in there. That's real close to that port. I'm going to back it out just a little bit here. Still got that spot. And is that a hollow just over the port or not? Now to me that looks so good, almost 3/4 of the way around. It takes one little dip, and I'm not going to worry about that one little dip. Alright, now we're going to come back out here. Okay, lightly tension the 4 jaws here. For a casting that we're relying on O-ring surfaces and a weld buildup that we're gonna have to reset up and redial in here, we're holding it good. I'm happy with what we got. We're going to pull the indicator out of here and we're going to spin it and take a look at it. That, you know, you had a pointer right there, you can't see that moving. Alright, I'm happy with that. Let's get set up with a tool bit. Okay, before we get to turning on the space here, we're going to go ahead and we're going to pull these helicoils out. So I'm going to go ahead and I can get in here with the scribe and get the pliers on here, and we can just should be able to grab them and just spin them out backwards here, just because when you pull them inward, it's just like the driver. And it kind of loosens them and lets them come out of the bore. They still do look pretty good in there, but we're not going to be able to build up here and save those, so we're going to completely eliminate this hole and create a slot, and then we're going to weld that back up. Alright, let's go to the next. We're just going to go right around till we remove them all, and I think we can grab a hold of each one of these at a certain spot like that. Started. There we go. Oh, that one broke on me. Might have to grab that one. Might have to rotary burr in from the outside. We'll see. This one here, half of the helicoil is actually sitting outside, open on the side here, so I'm actually able to unscrew it by just going a slight bit at a time. Here we go. That was pretty effective also. One of my favorite little homemade tools, I guess you'd call it, would be a needle gun. Needle gun is the same thing as a rattle gun. Or some people would call it a scaler or whatever. But this is one of the needles out of here. These are extremely hard, and I sand a point on the end of it, so it's almost like a center punch, but a little bit finer. And this I find sometimes without any effort is able to go in and really kind of like right now I'm just trying to raise the metal up just a little bit. Go ahead and get that little coil sticking out there, and we'll see if we can get it pried out, and then we're just going to go ahead and pull this out like we did on the other ones there. Okay, there we go. Alright, no more threads in any one of these. So now we can come across safely and hit the face without hitting anything hard. Everything will be just the aluminum material.